What comes to your mind when you hear the word chromium? If you thought stainless steel or tools, you're absolutely right. Chromium is a metal which, when added to materials, induces toughness, rigidity, and resistance to chemical corrosion. Did you know that South Africa has got the largest known deposits of chromium in the world? Therefore, it makes sense to exploit this metal and pursue a research field that primarily uses this material. Chromium lies in the center of the periodic table, together with other metals of similar properties. They are bright, shiny, they have high melting points, and they are collectively called transition metals. But what makes chromium special? That is its magnetic property. Chromium is described as an antiferromagnet. Simply put, it is a weak magnet. What makes it weak? It's the way in which the electron spins are aligned in chromium. They are aligned anti-parallel to each other. If they were aligned in the same direction, it would have been a strong magnet. But remember, chromium is not an antiferromagnet at all temperatures. It undergoes a transition from a disordered paramagnetic state to an ordered antiferromagnetic state at a temperature called the Néel temperature, abbreviated as Tn. In our study, we observed that on doping chromium with rhenium and vanadium, which are also transition metals, we can push this temperature down all the way to the absolute zero of temperature. This phenomenon is called quantum criticality, and the point at which this occurs is called the quantum critical point. In the quantum critical state, the properties differ. They're remarkably different from their conventional state. We also observe that one of the alloys with 10.4% vanadium can be driven to superconductivity. What is superconductivity? Zero resistance to the flow of current. So quantum criticality occurs at the absolute zero of temperature, which is minus 273 degrees Celsius. That's the temperature in outer space. Isn't it amazing to study physics at such low temperatures? So superconductivity, quantum criticality, these are the focus of my thesis. So through my PhD journey, I have been able to observe and study new realms of physics, and our results have contributed towards expanding the known horizons of science. A special thank you to the Postgraduate Center for this wonderful new initiative. Distinguished judges, ladies and gentlemen, I thank you for your attention.
The University of Johannesburg. Rethink, reinvent.